Any questions, anyone? Don't all jump at once.
I'm just wondering, Mark, have you done anything more with setting up your waveguides for the experiment to actually be able to put a sample inside a waveguide configuration?
Oh yes. So yeah, sorry, I forgot to mention that. So we ordered some copper, and we're gonna plate it silver. I got the dimensions set up, and I sent it over to a machine shop to cut it, and I told them that the measurements I gave them are very precise. It needs to be off. It can't be off by more than 1,000th of an inch, and I'm still waiting for that to come back. And when it comes back, we'll be able to move to the next phase and you know, start doing the experimentation. But I do have the forward and aft power set up with those 3 cross guides and the power meters, and those are working correctly. So it's a lot of work, like you said. It's a lot of work to do something like this, and it's really like next level engineering to work with RF. Extremely confusing stuff.
Well,
and thank you all. Yeah. Thank you very much. You've been very helpful. There's very few waveguide experts that I've been able to find that would talk to me.
And again, I wouldn't even qualify myself as an expert. I just have some experience.
Right. Yeah. I don't know if there is any experts, because it's almost a dying field. Like, who deals in this?
Well, you know, in the military circles, there are people who have a lot of expertise in that sort of thing. And that's why I really like the idea of having some people on who may have connections with, you know, some information about vehicles that really do exist already. Anything we can glean further from them would be really nice. But I think it's great you're trying all these things. I like what you're doing.
Yep. Thank you for all your help, Tanya. That was really helpful.
Well, and thank you, Tanya, for coming back as well, because we haven't seen you in a while, ma'am.
Well, I'm usually here. I just keep I keep the video off because I'm rocking around and I'm eating and things like that. So, I've followed almost everything today. I thought it was a really great discussion today. Really good presentations. I really enjoyed it.
Yeah,
even the little, you know, flare up.
Well, I was really excited to have David present. I mean, it was just that was just like a tour de force, you know. Now the math, admittedly, you're way beyond me on that, but you know.
I mean, I really appreciated David's presentation too. I actually started out in gravitational physics in my senior year of undergraduate. That was my planned course, was to go and do Kaluza-Klein theory, actually, you know, the higher dimensional space-time idea, but I wound up going into experimental physics instead. So yeah, I really appreciate all the mind work that has to go into studying so many different theories. And so that's quite interesting.
There's definitely a lot of that. But I found, and Jeremiah has noticed this as well, and so has Tim, that there's many different experiments that have been tried with claimed positive results that all come back to this dynamic nuclear orientation theory, like spinning superconducting disks. Like, what is that doing on the nuclear level? Is orientation happening there? If you add a magnetic field, maybe there is. You know, it all really comes back to the same experiment, which is something that a PhD physicist had written a paper on, peer-reviewed, claiming, and then claimed later on that it worked. So I think that's to start with.
Yeah, and I'm based on my experience, just reviewing experiments, and again, David touched on this. If I was going to say what does it come back to, I would say rotation. Now that could come back to the NMR thing, but I'm a little bit more general. I'm saying that the rotating, what I've seen is rotating magnetic fields. You know, when you get these positive results, it seems like that is kind of one of the things that pops back up again, you know. And again, I think David was saying that torsion was embedded in a lot of these other theories. And that was kind of what intrigued me with it, is this aspect of rotation. So now, again, that could be NMR, it could be related to it, could be the same underlying mechanism, you know, but for me, that's kind of the piece, so.
But that's why it's really interesting about the magnetic energy converters. When you start to get into these energy devices, it's those rotating magnetic fields, and there's always a component that makes them seem less, less mass. There's weightlessness that comes along with those technologies. So that's something that I've been interested in for a while. I don't fully understand it, but I guess the first speaker was touching upon that too.
Yeah, rotating magnetic fields. I've heard a lot about that, and it would also fit in with this theory, because if you can rotate a magnetic field around a sample, then what are you doing to the electrons? What are you doing to the core? Is there orientation happening because the spins are aligning or something like that? It all seems to fit together with Alsfon, and I think there's more than one way to do this. Probably more than a dozen ways to achieve the same result, which would explain why there's a plethora of different shaped craft out there.
Well, and if I could jump in again, and this might be off topic, but when you're talking about experiments, and for me again, when you're talking about the mythology of gravity modification, right? I mean, obviously superconductors made an entrance with Pogleonov, but one of the other ones that's always intrigued me is bismuth. And so I guess the two chemicals that seem to pop up again are bismuth and mercury. Mercury, it makes sense for so many different reasons, because it's a liquid metal. It has unique, physical properties, right? And so that makes sense. But bismuth to me never made sense. But yet it comes up again and again and again. And
there's something special about bismuth. It has some property. I can't think of what.
It's mildly diamagnetic, But what's also interesting was, let me see. I'm trying to think of some of the different things I've heard. I met someone who did experiments with it, and they said something about the E field when they were running current through it. The E field propagated strangely. It was like, they said the E field didn't propagate like it did with other metals. They were doing conductivity testing. And then the arts parts, right? That old UFO thing, which may be related to the TTSA, I'm not sure. Arts parts was supposed to be a bismuth magnesium bilayer. And actually, I had heard references about that with gravity modification going back before arts parts. So I thought that was interesting. And then for what it's worth, taking it just a step further out, one of the theories that was out there was the reason they had these weird effects on the Philadelphia experiment was during World War II, when they were trying to put these ships together, I guess they were having lead shortages because they used it for bullets. So they were running bismuth in the welds. And so I think that was John Daring who'd said that. He said they would have had unpredictable results because it's mildly diamagnetic. And he said the whole welds.
It's the most naturally diamagnetic material.
Yeah. Okay. Well, there you go. Now, I don't necessarily know if the diamagnetism itself is what does it. I don't think so, but maybe that's a
high spin too. It has a 9/2 spin ratio. Very few materials have that.
It's intriguing, isn't it? Though I mean, again, for me, I'm just seeing a pattern in the mythology. That's all.
There's a lot of mythology about bismuth. Also, something interesting about bismuth is it's kind of rare, and it's super cheap. Like you can buy a pound of bismuth for around $3-4. That's because the only known use for bismuth is Pepto-Bismol, which is like for upset stomachs. If we could find any usage for bismuth in anti-gravity spacecraft, buy bismuth, because it'll become more valuable than gold.
Actually, if I could jump in really quick, rather than try and refine Pepto-Bismol, which I'm sure would be a nightmare, it would be interesting, but painful, I'm sure. You can get, I believe, pure bismuth in lead-free deer shot or buckshot for shotguns. That's what they use instead of lead. So, and you can buy that and melt it down.
Yeah, there is no need. We've got plenty of bismuth. This is from Mark's private collection of bismuth.
Oh, of course.
But this is only a tiny sample of it. I mean, he's got about 3 times this weight. And this thing is freaking heavy. We've been screwing around with it, working on its crystallization formations and testing other parameters with it. We actually use some bismuth powder mixed in with a crete type compound, a type of cement, in between 2 carbon or graphite plates to test a variation of the Pogleonov pore experiment. But yeah, bismuth does offer a lot of really interesting properties, and it's pretty unique in terms of its diamagnetism. As far as a natural element, even though it's weakly diamagnetic, it's still important to point out that it's one of the strongest diamagnetic natural elements that we have.
Now, it's possible though that if it does play, like again with Art's parts, maybe the role that it plays has nothing to do with the diamagnetism. Maybe it has to do with it functioning as a metamaterial, right? I mean, if you
I
put it in
very
this,
much agree with that. Yeah, diamagnetism may just be an interesting property of one of its many properties that we have not yet discovered because we haven't really taken it through its paces and seen what it can do.
yeah, I mean, because I've met people who've experimented with it and haven't seen anything. So
Rob Chambers just mentioned something that I noticed before. Bob Lazar got all excited about element 115, which isn't stable, by the way. But right above element 115 in the same family, the first element that's actually stable is bismuth.
okay, well, there you go. Yeah. So it checks all of the boxes for UFO conspiracy theory materials. You know, we're set. Now, whether or not it actually does anything is another story. But as far as mythology goes, it's the Holy Grail.
Right. Another thing that I didn't touch on yet was the this was my take on the Alzheimer's experiment of like the theory behind it, and I'll get into David and Frederick's Alzheimer's theory after that. Basically, this is something that I asked Jack Sarfati before. He didn't have an answer for it. He said that it's impossible to get rid of inertial mass. So I had asked him, where does inertial mass come from in the first place? Answer that, and then you can tell me that it's impossible or possible. Or, well,
equivalence principle. That was his answer.
Well, there is an equivalence principle with gravity. We know that. But well, let's say let's look at the core of an atom. That's where all the mass is stored. So what's in the core of an atom is a whole bunch of electromagnetic fields that are spun in on themselves. That's what protons and neutrons are. So what do you have? What happens when you have these fields that are, you know, electromagnetic fields that are spinning on themselves? You basically have gyroscopes or complex gyroscopes. They're not just, it's not just one spin. There might be a spiral and then coming back. There can be all different variations of what's actually happening there. But ultimately they're spinning. And the second law of thermodynamics states that everything is going to a state of higher and higher entropy. More and more complex, you know, variations, randomness. So I would assume that in the core of an atom, you probably have lots of random spins going on around. So if you were to like take a baseball, for instance, and you throw it, the inertial mass, the inertial thrust that you're giving that baseball can be converted into energizing or slowing down the subatomic spins in the cores of all those atoms inside that baseball, and that's where the energy is being stored. So if the and because there's so many random spins going on in the core, therefore the inertial mass will be equivalent in all directions. But if you were able to orient the subatomic particles in the core of the atom, then along its plane and axes, the craft will be essentially weightless, but only along its plane and axes. Which explains why flying saucers were seen to like slowly tilt and then they shoot off along the axis, or they can fly very rapidly along their plane. Seems to you know, correlate with this theory. And you basically, by orienting all the subatomic particles in the core of in the craft and its surrounding objects, you'd also make surrounding things weightless as well. And David Alzfon or Frederick Alzfon had a different theory. Todd, we'll get to yours next. I know there's more than one theory, more than two. And he said that gravity is also coming from the core of the atom, and we know that there's randomness over there in the core of the atom. So if the field is, the gravitic field is emanating from the core of the atom, and the core of the atom is random, or the spins are random, so you'd expect the gravitic field to be, you know, completely random and incoherent. By creating coherent matter, which is what we're doing, we're getting all the spins aligned. Gravity will then have to do work on the craft in order to make it incoherent, in order to attach to it, in order to you know, react with it, and that essentially cools down the gravitic field. Also, and it's important to note, this effect is not immediate. It's a build-up effect, and you know, over time, you slowly build up the dynamic nuclear orientation of the craft to a point where you're losing more and more weight or inertial mass, and then you're able to use a secondary system such as light, or there's M drive, and there's a lot of other potential methods to actually create the thrust that's needed. But if you only weigh 1% or less of the weight of the craft, the thrust necessary is negligible. Todd, you were going to say something?
Oh, and Hector might be, he had a bunch of comments about bismuth. I don't know if you're open to that or not, but Hector is pounding them out in chat right now.
I was just going to mention in terms of origin of mass that, yeah, it's related to superconductivity because we don't understand the mass of the Cooper pair. So you get two electrons that pair up and there's this additional mass that is acquired and no one understands that. So you could say it could be related to what's going on for inertial mass, like how, the question that was asked to Jack, how does that come about? And basically through the conformal gravity, I mean, it's related to like holography as well. So, I mean, Randall Mills had his soap bubble thing. I mean, you could say that there's like some things stored on the boundary of that soap bubble and say it's a hologram, right? So this origin of mass thing will relate to superconductivity, and it's about understanding how basically it's like a phase transition of the quantum vacuum itself. So I mean, someone's got to figure that out at some point. And at really high energies, mass doesn't matter. So effectively, it gets to a point at really high energies, everything's massless anyways. It doesn't matter. And so that's effectively a different phase. And when you cool down from that, and you in the early universe, as you start expanding, eventually there's a phase transition that occurs and particles acquire mass, just like the Higgs mechanism in electroweak theory. And there's a gravitational Higgs mechanism that is, very interesting, and people are just starting to figure out in academia maybe how that connects to, visible reality. So once that happens and people figure it out and really connect it to superconductivity, that could help. But who knows, that could be 5 years away or 100 years away.
Or 50 years in the past.
Yeah, that as well. There's a lot on the internet. I think most problems have already been solved. It's about putting it all together.
Amen.
Yeah, and a lot of digging.
Well, Mark, yes. When you have a bunch of spinning charged particles, all compacted into a nucleus or a matter, and you accelerate that matter, according to Lamour's power equation, the amount of power radiated has to go up. Well, that energy has to come from somewhere. Well, it comes from the work you're doing to accelerate it. And so that power being radiated away, that is the dissipation that I'm talking about, that Jack's talking about, that, I'm talking about damping in my model. But it's that when you try to accelerate matter, you excite it, and the Lamour precession frequency goes up and it radiates more power. And it's the same as what I was saying before to David, is when you lift something in a gravitational field, you're exciting the particles, their acceleration goes up, the Lamour frequency goes up, you're opposing time dilation, and you have to do work to give it that energy to do that. And so that is the same. Gravitational mass and inertial mass are the same thing. And that's how it works. Now, to nullify the weight in this model, you have to have a pump. So you use the magnetic field to pump the frequency up to a very high Lamour frequency, and then let it free fall in whatever direction you're directing that gradient in the magnetic field. If you direct the gradient upwards, you'll free fall up. And it's the same as being massless.
Okay. Another thing I just want to explain to everyone, what we're talking about by Lamour frequency is the precession of the precession of the axes. Like Earth has an axis, it's 23 degrees off, the sun's axis, and it rotates around itself every like 25,000 years or so. What they call it the precession of the equinoxes. So that is what we're talking about with Lamour precession. Also, there's a lot of different Lamour precessions, because you can precess the core of the atom If you're persisting the core of the atom, it depends which atom you're talking about. If you're talking, or molecule, Todd is working with water, deionized water. It has a different Larmor precession of the nucleus than, let's say, bismuth. Yeah, there's a chart. And also for the unpaired electrons, or for the valence electrons, it's all the same. It's 28.025 gigahertz per Tesla. But if you wanted to go for a different row of electrons as you get closer to the core, the frequencies change. I believe they go up. And there's a lot of different Larmor precessions that we can hit. Todd is working in the megahertz range, which directly interacts with the core. And I'm working in the gigahertz range, which works with the electrons, which then interact with the core through hyperfine coupling. So there's many different methods of trying it. And there's also the one where you're not using any RF at all. You're just spinning it around, which is easy alzaphon, as we call it. And that method is probably a lot cheaper to replicate if anyone wanted to try it. But it's there's a lot of problems of having a craft with a huge spinning disk in it, which we don't really have to get into. Obviously, the craft will spin in the opposite direction, and you'd have this huge aluminum disk spinning around. So there's a lot of disadvantages.
A gradient in the acceleration of those atoms, and it'll cause them to precess at higher and higher power depending on the acceleration, which depends on the radius on the disk that's spinning. So it's a cool experiment. I'm anxious to see how it works out.
If you want any of these discs, to try it yourself,
I may want a smaller one. Mine's like 24 inches in diameter.
Well, we have 3 different sizes. I have the size over here, which is around 4 inches, and we have a 6-inch disc, and we also have the much larger 8-inch discs. And
I had 24 inches because I was making an energy storage device flywheel. But
what kind of aluminum is it?
I'd have to check. I think it's 6061.
Well, you have to check what 6061 is made out of and make sure that it's appropriate.
If it was pure aluminum, I'd be fine because aluminum would precess. I mean, it has a precession more frequency, so it's got an angular momentum already, so it should work.
Okay, we can try them all. The problem is making that coil. I was having a conversation with Jeremiah. If you can unmute yourself, Jeremiah, about the one. Well, we were having a conversation with Todd and Jeremiah about the coil configuration for the pulsed application of easy alzaphon. And
yeah, I was thinking about that too, Mark. And the specifically the thing that you haven't mentioned yet that you're really on about, and Todd pointed out, is the angle, the taper of the coil. This really important factor of a divergent or a gradient field being produced by that coil. Let's talk about that.
Yes, yeah. Todd was mentioning in a comment earlier that you would want the field to be stronger on one side than on the other. And I was looking at the ARV picture, and I noticed, hey, the coil is tapered. Would that would that produce that effect? And Todd was like, yeah, it probably would. Another way to do it is to offset it. But if you had a tapered coil, exactly as is shown in the ARV picture, it should produce some sort of effect. And that is how we plan on doing the next coil. When I get all the components in, and we'll build that coil. It should look really nice.
Yeah, and having a loop have a strong magnetic field gradient because the field drops off like 1/z cubed. So so it'll have a very strong gradient above the coil, which is what you want.
Yeah, it'll be interesting, Todd, to see your results too, because you're going to be able to test that gradient field in a more specific and refined way. So that will actually give us valuable data to assess engineering futures.
Robert O'Keefe wrote that he assumed that off-world technology would not have the same periodic chart. I would disagree with that. I think the only common denominator of our entire universe is our periodic chart, but they would have different different variations of the different makeups of the materials of the isotopes.
Isotopes.
Right. They would have different isotopes depending on which supernova created their solar system. So that is a possibility. And there's different types of supernovas, different energy levels, create different elements, and different age can create different isotopes, some of which are radioactive. Also, something interesting that Jeremy brought up about NMR and EPR is that the people who were involved in this in the early stages were then taken on to work for different secret projects, with the secret space program or the government.
Edward Mills Purcell, he won the Nobel Prize for NMR, of course, alongside I think Felix Bloch, and both of them had security clearances and did other classified research and stuff for Atomic Energy Agency and also EG&G in Area 51, believe it or not. Purcell headed the CIA's Project Rainbow, which was their whole study on radar reflectivity and electromagnetic frequency response in order to study and understand radar and radar return signals and that sort of the whole physics, the core underlying physics behind those principles. They're the ones that came up with that formula for radar signatures and returns, and that was the basis for the stealth fighter and understanding a lot of the physics that led to stealth technology. Of the existing stealth technology that we know about publicly, not including some of the more advanced stuff like the paint and these phase conjugate mirrors and these phase conjugate paints and stuff, which there's been a lot of research and stuff into that, and I know that those phase conjugate materials and some of the microwave phase conjugates were part of Project Skyvault, which is mentioned in Paul Laviolette's book on Secrets of Anti-Gravity Propulsion too.
Paul Laviolette was on the call with us today too, briefly.
Oh,
yeah.
Oh, really?
I saw him pop in, and I'm not sure what time he peeled out at, but he was here. So.
Oh, we would love to have him on to do a presentation. Also, something else that Jack erroneously said, that it's impossible to shoot these craft down. I call bullshit to that because it was done in 1947. How was it done in 1947 with Roswell and the previous crash? Well, they turned on a new form of advanced radar. Now, what is radar? Radar is pulse microwave wave.
How do you know this, Mark?
I'm not sure exactly where I read it, but I think it was in The Day After Roswell by Philip J. Corso. I talked about
if you're so smart, why do you smoke cigarettes? I'm just kidding.
You know who would know this? Ron Keating.
That's a good question. That's
the case of the microwave measurements that were being done on that craft. I bet you he has this memorized and knows exactly where the report came from.
Well, if you were to hit a craft that works using microwaves to make it weightless, so it really doesn't have much of a propulsion system. If you were to hit it at its Larmor frequency, which it's broadcasting to the world, you would be able to interfere with its weightless system, its inertial mass dampening or gravity dampening system. And so long as you interfere with it, just at 1% or whatever, you suddenly make the craft a lot heavier than it can propel, and boom, it'll crash. So.
Yeah, Mark Fiorentino said he thought he heard the craft was hit by a lightning bolt as it flew through a storm. But
I've heard that theory as well.
I do think it's interesting. Like now, if the craft is invisible, then that does present issues. But that's why I thought like lasers might be the way to go. If you were going to try and shoot one down. Although I don't want to sound, I don't want to sound too militaristic, I guess. It just, it's an intriguing question. That's probably all.
I just wanted to add that since I've been reading up on triangular UFOs, a lot of them fly very low. So they're below the radar level. So I think that's one way they avoid getting hit by it.
Well, and one of the things that's really interested me is, and I've again, these are all rumors. All of us have heard these in the past, but Frank Milburn had mentioned underwater UFOs, right? That submarine captains are reporting, and And this was in the part of the Begun-Sadat report that we did the interview on yesterday. That was kind of intriguing also. And I thought, well, there are a few different reasons that you might want to do that, but one of them would be stealth, right? That'd be a way to remain stealthy. So.
Also, something that David Al-Zafan brought up, and I haven't been able to verify this yet, is that through dynamic orientation, it is possible to make the craft invisible as well. If you think about why are things visible in the first place, it's because they're interacting with the electron field. They're not interacting with the nucleus. So if you can orient the electrons well enough, then from certain angles, not from all angles, the craft will become invisible to light. Light would just travel right through it, with some variation around the edges where the dynamic orientation isn't as perfect, which is pretty much what we see.
I think that's the first time I've heard that, Mark, that it actually made sense to me.
Oh, he mentioned it a couple times in the.
Oh, I know he mentioned it. I guess I never quite, ran through it in my head to grasp the concept of why. Should have been paying more attention, I guess.
I think that these.
Isn't that always the case?
Yeah.
These overlaps that we are noticing between, the research that's been done into invisibility and also nuclear magnetic resonance, and just this idea of the core of physics. Really, this is the core of physics, Wheeler-Feynman absorber theory, and stuff. I think that these are great questions, and this is a great direction for this whole conference. I just thank everyone for being here and taking part of it. We're nearing 5.5 hours on the stream, the live stream, and I think the last one I did shut off after 5.5 hours.
You know what? I think I should probably go. So I think it's probably time to close up shop for this evening.
I could go for another several hours. We'll start a new one and keep going.
More power to you. Thanks, guys. I'm signing.
Our human stocks are down 50% since about an hour ago, so it probably is a good time to close out. I think most people have already gone to dinner. But thank you again for everybody.
Yeah, I will end the conference then. Thank you to everyone. Todd and Mark, thank you for presenting there at the end, both of you gentlemen. And thank you for everyone who attended. This has been a surprising conference, and I think we gathered a lot of new perspectives. So
it was great to have David. I want to see more of those gravity research guys come back on for the quantumgravityresearch.org. Those guys. That was awesome to have David Chester on today. He really hit the ball out of the park.
Yeah,
thank you. Appreciate it.
Okay,
and,
well,
I'll say it again publicly real quick. Hector, we would love to have you on at some point if there's anything you can talk about. We would really love to hear what's been going on for the last 15, 16 years on all your research.
And I know there's a lot that he can't talk about.
I know he's got investment in it, and there's vested interest in it, but man, there's got to be something. I mean, he knows so much, and it can't all be secret information about his tech and their company's tech, about Gravitech. There's got to be something, right?
Yeah. Well,
he knows too much. He does.
Okay, so that's it for today, guys. Thank you again, and have a great weekend.
Take care. Peace. Live long and prosper.